Bronsted-Lowry acids.
You got any mean comments yet on YouTube?
I haven't really looked. This expands on the Arrhenius definition of acids and bases. And the key to remember about Bronsted-Lowry is that it's a more general definition. And it does not involve water. Okay, it does not involve water. It does not. It doesn't have to. And I'm going to be more specific. It doesn't involve aqueous solutions, something dissolved in water. So this allows you to talk about acids and bases that may not be actually in an aqueous solution. Okay, so by definition, a Bronsted-Lowry acid. Does anyone from your reading remember it? It's very good. Gives what? Very good. It is called a proton, which we know as H plus donor. It's a proton donor. And a Bronsted-Lowry base is defined as, anyone? Yeah. They usually say acceptor, but yes, means the same thing. Okay, it is a proton donor acceptor. So anything that can donate a proton is now considered a Bronsted-Lowry acid. Anything that can receive a proton is considered a Bronsted-Lowry base. Notice there is no mention of what ion?
OH.
Very good. There is no mention of hydroxide ion. Now, this allows us to establish, with those two definitions, what are called conjugate acid-base pairs. Conjugate acid-base pairs, and if you can remember this one fact about a conjugate acid-base pair, you're going to nail it. They differ by one H plus, or what we call a proton. The acid has one more H plus than the base. So before we get into some equations, I want to give you some examples. HNO3 we know is what acid? Close. Nitric. Nitric acid. Okay? This is what we call the acid HNO3, and if I just take the NO3, we call this I abbreviate it CB, but it stands for conjugate base. The conjugate base. And I want you to notice that NO3 is very similar to HNO3. The only difference is it's lacking what? One H plus. Let's go the other way now. If I said to you, am I going too fast?
Is that C13 or
CB. Sorry about that. All right, let me give everyone a chance to catch up.
And you spelled donor wrong.
Yeah, you did.
Oh, E-O-R. Thank you. When I wrote that, I thought, I was wondering. I should have asked.
These people this weekend tried to argue with me at work about how to spell zucchini.
Did you get him?
Well, he spelled it, and it was like Z-U-C-C-I-N-I, and I was like, that's
Where are you working?
fine. Webs.
And where did the discussion come up?
They were like writing it on the specials board.
Okay.
And then he's like, does this look right? And I was like, no. I was like, there's an H and then an H, and he's like, no, this looks wrong. He's like, this doesn't go here. And I was like, oh, okay. And then he like wrote it, and then some other kid was like, there's an H in it, and I was like, and then he's like, yes, so this one.
Ha. Way to go, Zoe. Hey, that's stereotypical.
Hey, I'm a dishwasher.
NH3.
See what I mean?
Zoe, I'm band of brothers. We're sticking together here. Eeyore, you stop those comments. Now,
Can I light a match on fire?
no, you cannot light a match on fire. NH3, what is it? That's CH4. NH3, what is it? I'm going with the Kingfisher. Ammonia.
I just,
You did?
yeah.
I'm sorry, did not hear it.
I heard it.
Can you please tell me the CA, the conjugate acid? Thank NH4 what? There you go. And we call this ammonium. This is the base, and we call this the CA, or the conjugate acid,
Wait, what's nothing?
CH4. Now,
Ammonium.
whoa. Eeyore, stop.
I think there's two M's. Yeah, there is.
It's not my day.
I'm gonna spell it.
No, you're right. Now, oh guys, I figured out another way to put these online. I'm just going to start putting them on my normal website, and there'll be a link. Okay, so it'll say acid base 1, acid base 2, acid base 3. So instead of using YouTube, just go to my website and hit the link. It'll take you right there. It'll be under acids and bases, and underneath, you'll just see it on the main where the homework is. It'll say links.
I thought it said it does not involve aqueous solution. Yeah.
It doesn't have to. Very good. It does not have to. Hold on, real quick. When they say hook up the acid-base pairs, the acids and bases will be on the left. Ca we know is a base. That means water has to be the opposite. This is the acid. Now, hook up the conjugate acid by finding the one that has one more proton, and hook up now the other conjugate base because it has one less proton.
Okay.
Acid and base will always be on the left, and then your conjugate acid, conjugate base will be on the right, and you find the one that has one less or one more proton. Have a great one.
So I can match up. Oh my gosh.
Sorry for the misspelling.